we've taken a look at this picture here, and we said that Joe is smaller than Steve. And we used our Pac-Man symbol to represent this. And we said that we have to do the same thing to both sides to maintain the inequality. So if we make Joe a little bit bigger, we have to make Steve a little bit bigger, just to make sure that Joe is still smaller than Steve. So now we're going to add one more person. And this person is going to be the smallest of them all. This person's name is Carl. And what can we say about Carl? Well, Carl is smaller than Joe. Okay, so that means we can add another Pac-Man. So what we're doing here is essentially combining two inequalities. So we have Carl is smaller than Joe, and Joe is smaller than Steve. So we're combining two inequalities to kind of create an order from smallest to biggest. So Carl is smaller than Joe, and Joe is smaller than Steve. Or we can say that Joe is between Carl and Steve. So if we make Carl a little bit bigger, then we have to make Joe a little bit bigger, because we want to make sure that Carl is still smaller than Joe. Well, if we make Joe a little bit bigger, that means we have to make Steve a little bit bigger. So we're extending the ideas that we've learned to include three different things. So we have to do the same thing to all three sides to maintain both of these inequalities. So let's take a look at this idea with numbers. So instead of Carl, Joe, and Steve, how about I give you 1, 4, and 6? So between each pair of numbers, we have to put an inequality. Well, as always, the Pac-Man faces the bigger thing. So reading this left to right, we say 1 is less than 4, and 4 is less than 6. So we're combining two inequalities. Or in other words, we can say that 4 is between 1 and 6. All right, how about we put our detective caps back on and take a look at x? So what if I give you something like this? Well, it looks similar to the example above with 1, 4, and 6. And there we said that 4 is between 1 and 6. So in a similar way, we can say x is between 2 and 5. And let's put this on our number line. So we're saying that x is between 2 and 5. How do we represent that? Well, it's not equal to 2. It's not equal to 5. It's somewhere in between. So as a detective, you know that x is somewhere between 2 and 5. And I mentioned that we're looking at two inequalities combined. So we can read this as 2 is less than x. Or we could switch spots and say that x is greater than 2. This says the same exact thing because our Pac-Man faces the bigger thing. And this says x is less than 5. As a detective, you know that x is greater than 2 and it's less than 5. And that's what we represented on our number line. All right, let me give you another problem. Let's have some more clues for x. So we're saying x is less than -2, or it's greater than or equal to 1. So some different kind of clues here. So x is less than -2. So it's not equal to -2. It's less. So this is one area where x could be. Or it's greater than or equal to 1. So it could be equal to 1, or it could be greater than 1. So this is a different kind of combining inequalities. Up here, we could kind of confine x to a small area. It's between 2 and 5. Well, down here, we don't really know where x is. It's less than -2 or greater than or equal to 1. So as a detective, it's kind of hard to find. All right. So now that we've gotten an idea of that, how about we take things up a step? Find where x is and show it on a number line. And we have -16 is less than or equal to 3x minus 1, which is less than 11. All right, we kind of have that Carl, Joe, and Steve scenario, right? We have an order from smallest to biggest. It's a little messy, but we just have to find a way to get x by itself, and we do the same thing to all 3 sides to maintain both of these inequalities. So it's extending these ideas that we've learned just a step more. What can we do to get x closer to being by itself? We can get rid of that 1, and then we're left with -15 is less than or equal to 3x, which is less than 12. We did the same thing to all 3 sides. We have 3x in the middle. We want to get x by itself, so we divide by 3 on each side. And that leaves us with -5 is less than or equal to x, which is less than 4. In other words, x is between -5 and 4. So let's draw that on our number line. And let's rewrite this inequality just to make it a little more clear. I said that we're combining 2 equalities, so we can rewrite this as x is greater than or equal to -5. Again, they're just switching spots. And we have x is less than 4. Okay, so let's use these clues in purple to find x on the number line. So it's greater than or equal to -5. It could be equal to -5, or it could be greater. However, it says and. It says and it's less than 4. Okay, so it could be greater than -5, but it has to be less than 4. So x is going to be somewhere in this region right here. All right, let's try another. We have 12x minus 7 is less than or equal to 17, or 5x plus 8 is greater than 33. We have this or keyword in the middle, so that reminds us of this example up here, where we had x is less than -2, or x is greater than or equal to 1. So this is where x is kind of tricky to find, right? And we have 2 kind of random areas where x might be. All we're doing here is just making it a little more messy. We have 12x minus 7, and we just want to get x by itself. So this looks a little complicated, but all we're doing is we want to remove all the mess and get it back to something simple that looks like this example. All right, so this is 2 inequalities, but they're separate this time, so we can tackle them separately. On the left, we have 12x minus 7 is less than or equal to 17. To get x closer to being by itself, let's add 7 to both sides. And that leaves us with 12x is less than or equal to 24. Now we divide by 12 on both sides, and we get x is less than or equal to 2. That's part of where x could be. You're the detective, and That's how much you figured out so far, but we have a second half. So let's take a look at the right side. We have 5x plus 8 is greater than 33. Let's get closer to getting x by itself. We get rid of that 8 on both sides to maintain the inequality. Leaves us with 5x is greater than 33 minus 8 is 25. Now we can divide by 5 on both sides, leaving us with x is greater than 5. All right, so x is less than or equal to 2, or it's greater than 5. So we simplified it. We got x by itself, and now it looks like our original example. So a lot of algebra is going to be unwinding the mess and getting x by itself. And that's really what is going to be the challenge here, making sure we do the same thing on both sides and keeping things organized. So let's go ahead and put our clues on the number line. We have x is less than or equal to 2. Okay, less than or equal to 2, so it could be equal to 2, or less than 2. So let's put that line and arrow. That's somewhere x could be. Or it's greater than 5. So it's not equal to 5. So let's put an open circle and put an arrow going to the right. So these are two areas where x could be. X is kind of hard to find. You're the detective, and this is the best you can do. It's less than or equal to 2 or greater than 5. Up here, it was a little easier. You could narrow it down to a contained area. All right, and just a note, when you're doing these problems, they're going to be worded a little differently than what I have. Instead of saying find where x is, it'll say something like solve the inequality. That's the fancy way of saying it. And instead of show it on the number line, they'll say graph the solution. So these are the words that fancy math folks like to use. It makes them sound serious and professional. Well, I am neither serious nor professional, so I use simple words. Okay, all jokes aside, math folks like to talk like this because it's very precise language. Instead of saying find where x is, they like to say solve the inequality because it's more precise. However, you're learning this for the first time, and I think it makes more sense to use more informal ideas and explanations, like thinking you're a detective looking for X. And once you get that idea, once you develop your understanding, you can take it to that next level of improving your language, your communication. And you could think in terms of solving the inequality and graphing the solution. But if you see the fancy words for the first time, then that can be really intimidating and confusing. So take that as a tip to try to find a way to simplify anytime you're communicating with someone. Oftentimes, a difficult concept can be broken down into simple words and easy explanations. So I hope you're finding value in these videos, and I'll see you in the next one.